Welcome back to another exciting video. In this example, we are supposed to calculate the mass of chlorine gas formed at the anode when 5 Faradays of electricity is passed through molten sodium chloride. Chlorine has atomic mass of 35.5. 1 Faraday is equivalent to 96,500 coulombs, and this is an echo question in 2004. Now let's start with our solution. Okay, now the first thing for us to do is to write the ionic equation of this problem and then balance it. First, you have chlorine, right? And you have the electron that it's losing, and then you have chlorine gas, right? So you just balance the equation. Chlorine gas is always this way. So we have this gas, and then since chlorine is 2, we have 2 here, and that 2 electrons will balance the equation based on what we are having. Now if this equation is okay for this calculation, then we're going to be having this to be a gas, here to be Hs. All right, so here we're going to be having 2 Faradays, right, giving rise to what? This chlorine gas. And this is chlorine gas, so it's going to be 2 times the atomic mass, right? Okay, so what it means is 2 Faraday gives birth to 2 times 35.5 grams of chlorine gas, right? Okay, so let's write it down. 2 Faradays is equals to 2 times 35.5 is going to give you 71 grams, right? So it means 2 Faradays gives us what? 71 grams. Now what this equation also means is you can also balance this equation to look somehow proper, right? So this also can be written as this plus 2 electrons, right? Okay, so now what this means is if 2 Faradays, right, gives birth to 71 grams of chlorine gas, then what does 5 Faradays produce? That's what the question is asking. So let's write our simple equation. 2 Faradays gives us 71 grams. Then based on the question, 5 Faradays is going to give us x. So when you cross multiply now, x times 2f will give you 2fx. 71 times 5f is going to give you 71 gram times 5f. Now there are situations that you would like to substitute the value of the Faradays. It's all left for you to decide, but using this equation you can also eliminate the Faradays since both of them are of equal magnitude. So here we divide both sides by 2f to be left with x. 2f here, and here we have 71 grams times 5f divided by what? 2f, right? So this value will eliminate this value, so you have x is equals to 71 gram times, now this f can eliminate this f because if you won't put them as 96,500 coulomb, they will still cancel each other, so there is no need to repeating it over and over again, right? So here we're going to be having 2.5. 5 divided by 2 gives you what? 2.5. So our x will be equals to 71, right? Okay, first maybe we just multiply. Let's just multiply. If we take it from here, we can still do our multiplication. So we have let's leave this step. Let's leave this step. So here we have 71 times 5. So it's going to give you 355, right? Divided by 2. Is that okay? Because this times this is 5, this times this will give you 35, right? So if we divide it by 2, 2 into 3 is 1, remainder 1, 2 into 15 is 7, Remember 1, 2 into 15 again is 7, then 0.5. So we are going to be having that amount of mass. So it's going to give us 177.5 grams. So they say we should calculate the mass of chlorine gas. So the mass of chlorine gas that will be formed at the anode when 5 faradays of electricity is passed through molten sodium chloride is what? 175.5 grams. So this brings us to the end of this calculation. I'm going to be taking other beautiful examples again. I hope you follow suit to enjoy the workings. See you in the next video. Bye for now.